Okay, let's start with question 26. It says a cyclist is traveling at 21 kilometers an hour when she sees a stop sign ahead. So let's put her as a box. 21 kilometers per hour, and she weighs 73 kilograms. And 21 is 5.83 meters per second. And she's going to come to a stop. Calculate the acceleration. I'll probably go back to this formula. Pretty much have everything we need here. The distance is 15 meters. At 0 minus, okay, I solve for A. I already have it on the screen. Square that one, divide by 2, divide by 15. And it's backwards, so it's 1.13 meters per second squared. Calculate the acceleration of the cyclist. That's A. B, determine the coefficient of friction between the road and the bike. Let's take a look at that then. We have gravity, which is always the same, the normal force, and we have force of friction. These two are going to cancel each other out, but this will be mg, which equals 73 times 9.8, 715. And this will also be the normal force, which equals 715.4 newtons. And the force of friction, these two will cancel out, so the force of friction is actually the net force. So we can solve for that. F equals the mass is 73. Acceleration is 1.13. 73, 1.13 is 82.5 newtons as a force of friction. They want to know the coefficient of friction. Okay, so force of friction equals mu Fn. So 82.5 equals mu times the normal force, which is 715.4. Mu equals 0.12. Okay, and that's the answer for B. And that was question 26. Let's take a look at question 27. Let's squeeze that one in here. There's the back of the boat. It's going through the water like that. The water ski is being pulled behind the boat. Angle of 48 degrees with the back of the boat. So it's like this, 48 degrees. And they're basically asking you to find the components on the rope. So I'm just going to find the X and the Y component. X will be horizontal and Y will be the vertical. Y is sine, so this will be, oh, hold on, let's see what the tension is. 620. And this will be 620 cos 48. So we go 48 sine times 620, 461. And cos 48 times 620 is 415. If we go with significant digits, they're going to round them off at 2 digits, so that'll be 460, or they might even write 4.6 times 10 to the 2. Yeah, or 4.6 times 10 to the 2 and 4.1 for the horizontal and vertical. Let's take a look at the next question. Number 28. We have a toboggan with a mass of 15 kilograms to be pulled with an applied force at an angle. Okay, let's draw our toboggan. Looks like a box. Someone's pulling on this thing with 45 newtons at 40 degrees. And guess what's always here? Gravity's always there. We may not need that in this question, but it's an angle vector. Let's get rid of that angle. Let's break it into the two components, the up and the down, or up and sideways. So this one would be cos. So if I go, we'll write it out again. 45 cos 40. And and this would be 45 sine 40. So 40 cos is 34.5. And sine of 40 times 45 is 28.9. If I throw gravity in there for fun, that's 147 newtons. They are lifting with 28.9, so the toboggan would feel a little bit lighter, but this one, thankfully, they just gave you friction straight up. 28 newtons. There would be a normal force here. The normal force would have to add to that to balance that guy out, because this toboggan is not lifting up in the air or sinking into the ground. But now we just have a tug of war between these two forces. So I have 34.5 forward and 28 backwards. That will give me the final net force here of 6.5 newtons forward. And they want to know the acceleration, F equals ma. This has to be the net force, which is this one. So we're going to divide that by 15, and we get 0.43 meters per second squared for 28. 29. That's the old grocery cart question. It's being pushed. Okay, so we have a 42 kilogram grocery cart, and somebody's pushing on it. So they're pushing in the down direction, 30 degrees below horizontal. And they're pushing with a force of 450 newtons. And they should calculate the force of friction with the coefficient of 0.6, so I need the normal force. So we have to break this up. You know what always is there? Gravity's always there. So that's going to be 411.6 newtons. This will have a down component, which is going to make this cart feel heavier. There will be a normal force up here, which is going to be a little big, and we're going to have friction over here. These are all the forces on here, but this angle one is a nuisance, so we're going to split that guy out into the forward and the down component, and we also have gravity here. And we're going to break this up, so sine of 30, it's actually negative sine of 30. So it's going to be 225 newtons in the down direction, 30 cos times 450 is 389.7 in the forward direction. And now we need to find a normal force here that balances those two off. So if I take those two and add them up, so 411.6, 225, add that guy up there, my normal force would be 636.6 newtons. Okay, now we have the normal force, we can find friction. So force of friction equals mu F normal. And question 29, mu is 0.6. And the normal force was 636.6. Gravity is only 411, but it feels heavy because whoever's pushing on this cart is doing a lot of pushing down as opposed to just forward. So times 0.6, 381.96. Friction is almost the same as the forward force. But then when we draw the net force, up and down cancel. I will do a small net forward force of 7.74 newtons. And the cart weighs 42 kilograms, so we can find the acceleration. 7.74 equals 42 times A. A will equal 0.18. All right. Let's continue on with question 30. Question 30 is just a components question. There's a net force of the following three forces are being applied at the same time. Okay, so we got 40 newtons south. And we have 60 newtons to the north. And we also have a north 35 degrees east. So north 35 degrees east is going to be like this, of 30 newtons. That's up 60, that's down 60, and this we're going to have to break into the components. 35 degrees from 90, that's a 55 degree from the x-axis. So if we go cos 55 times 30, 17.2, and if I go 55 sine times 30, gives me 24.57. Got to add them up. 60 minus 40 plus that gives me 44.57. And we're going to put them back together again. So that's up and a little bit to the right. And I need to find this resultant is the side here, so that's going to be Pythagorean. And 70.2. I got 47.77 newtons. And you have to assign a direction to that, mostly north with some east. I use tan to get the angle, 17.2 divided by 44.57, and then inverse tan, and I get 21 degrees for number 30. And the last question, 31. Two boxes are being pushed. There's a diagram there. Okay, let's take a look. A 40 and a 20. And 20. And they have the picture, well, they have it written over here. Okay. Calculate the acceleration of both boxes. And then the force on the second box. So to redraw this as a whole system, you're going to have a 60 kilogram box with 48 newtons to the side. No mention of friction or anything, so that is the net force. F equals ma. 48 equals 60 times A. A will equal 0.8 meters per second squared. So that's the answer for A. B says, just look at that little block. Well, that little block is 20 kilograms. It's being pushed by the big block with some unknown force. But that's the only force on it, and we know its acceleration rate is 0.8 meters per second squared. So this just becomes F equals ma, 20 times 0.8. We'll do it anyway, 16 newtons.